This screencast is on acid-base properties of salts. So we want to talk more extensively about the different types of salts. Normally, when you think of an acid-base reaction, remember we learned that an acid plus a base will form a salt plus water. And we typically think of a salt as being neutral, but there are acidic salts, neutral salts, and basic salts. So let's talk a little bit about how to recognize those types of salts, and then we'll look at the steps that we need to take to calculate the pH of those salt solutions. So neutral salts. Neutral salts come from, the cation comes from a strong base, and the anion comes from a strong acid. The pH of a neutral salt will be 7. So here are some examples of some neutral salts. Now, it is always true of any salt. The cation of the salt came from the base. The anion from the salt came from the acid. If the salt, cation, and anion both came from strong acid and strong base, then that means it's a neutral salt. Sort of like their strengths cancel out and neutralize one another. So let's look at KCl. KCl would have come from potassium hydroxide, a strong base, and HCl, hydrochloric acid. Those are the parent acid and base. KNO3, the cation comes from the base, so KOH, and the anion would have come from nitric acid, HNO3, another one of our strong acids. Sodium chloride. Sodium comes from sodium hydroxide, the strong base, and HCl is where the chlorine comes from. Strong base, strong acid. Sodium nitrate. Sodium comes from NaOH again, cation from the base. HNO3 would have been the acid that this came from. So you've got to be able to kind of think in terms of what acid and base did it come from. These salts simply dissociate in water because they're soluble salts. Remember your solubility rules. 1A metals are always soluble. Halide ions are soluble. So these are going to simply dissociate. pH would be equal to 7 automatically. Basic salts. The pH of a basic salt solution is going to be greater than 7, thus they're basic. So how do you recognize a basic salt? Well, remember the cation of your salt always came from the base. The anion always comes from an acid. Well, if it's a basic salt, the base was a strong base, but the acid involved was a weak acid. So the strong base sort of trumps the weak acid, and it controls the pH, so it's going to have a basic pH. Here's some examples of some basic salts. So let's look at the cation. Sodium would have come from sodium hydroxide. There's your strong base. And the anion came from the acid, so put a hydrogen in front of it, HC2H3O2. That's our weak acid, acetic acid. Thus, that's a basic salt. For KCN, the K came from the strong base potassium hydroxide, and the acid was HCN, a weak acid. Sodium fluoride. Sodium would have come from sodium hydroxide, strong base, and HF would have been the acid that the F came from. So weak acid. Acidic salts. For an acidic salt, the cation is the conjugate acid of a weak base. Again, the cation is the conjugate acid of a weak base, and the anion is from a strong acid. So since the strong component that it came from was the acid, it's going to be an acidic salt. Therefore, the pH of that solution will be less than 7. We will learn how to get the exact pH in our calculations. Here are two acidic salts. Let's look at the cation and the anion. So here, the cation is ammonium. Well, ammonium came from the weak base NH3. That's for both cases. Chlorine came from hydrochloric acid, a strong acid. That's why it's an acidic salt. The NO3 comes from nitric acid, another strong acid. Now, there's also a possibility that you may have a salt where the cation came from a weak acid and the anion came, I'm sorry, the cation came from a weak base and the anion came from a weak acid. So if you have this particular type of salt, the only way to tell if it's acidic or basic is you got to compare your Ka to Kb, and whichever was the greatest wins. So if the Ka was larger, it's going to end up being an acidic salt. If the Kb is larger, then it's going to be a basic salt. Here's some examples of those. So here you see NH4, again, that came from the weak base NH3. And with the acetate ion, that comes from HC2H3O2, a weak acid. Now, if their Ka and Kb's are equal, it would be a neutral salt. So again, if the Ka equals Kb, then it's a neutral salt. If the Ka is greater than Kb, then it's an acidic salt. And if the Ka is less than Kb, it's a basic salt. Okay, with this one, this came from HCN, another weak acid. Oh, this is what I just repeated. I could not remember if I had it on here or not. So if Ka is greater than Kb, the solution is acidic. If Ka is less than Kb, the solution is basic. If Ka equals Kb, the solution is neutral. Now you also need to remember this. This is a formula that's very important. Ka times Kb is always equal to Kw. The Ka times the Kb, and this is talking about when you have a conjugate acid-base pair, so like with ammonia and the ammonium ion. Ka times Kb equals Kw, which is 1 times 10 to the negative 14. Steps to solving these problems. The first thing you have to do is dissociate your salt. These salts are always going to be assumed to dissociate 100%, and this is a stoichiometry problem, not an equilibrium problem, so it's going to be a 100% shift. If your salt was acidic, you're going to take the cation from the salt to start the next part, but you need to find the Ka of it, and you're going to react it with water. If the salt was basic, you're going to take the anion from the salt, find its Kb because it's basic, and then react it with water. And that's how you're going to get your reaction to use for the second step here. We're going to use the reaction of the ion and water, and we're going to solve this one as an equilibrium problem. So we're going to ice the problem. Depending on if you have an H plus or an OH minus that your X is equal to, you solve for the pH ultimately. Now we're going to be using problems 9 and 10 in our practice problems packet for this. So I'm going to stop the video here at this problem, and then the next video we'll pick up with the 2 sample problems.